All right, welcome back. We are MAPD724. That's Advanced iOS Development in the Winter 2021 semester, and it's week 6, part 1 of our broadcast. Maybe we'll do a couple parts today, as this will be probably a slightly longer session than normal. But then we have some short sessions, some long sessions. This is how we go, how we roll. This week on the docket, if you notice, is maps, geolocation, geofencing, and orientation and motion. This is stuff that you should know how to do. And what I've done in the online inside of the course shell, I've got quite a bit of information, and there are a couple of apps that for practice, if you want to learn how to do that, it's in here. So it talks about accelerometer, physics, rotation, the gyroscope, all kinds of little things that we'll probably use in the second half of the semester, but it's here for your reference. However, at the same time, we also have next week, we have this midterm test where you're going to build a small app in class. It's worth 15% of your final grade, so it's not a joke, and all that kind of stuff. So I want to do a little in-class exercise to help you out, and it'll be in-class exercise number 3. So that's what we're going to do. We're going to build a part of a small game, and you're going to build the second part next week. So this way, when we build it together, you'll know what to do. I'm going to post this video later on, so hopefully you'll be able to use it. Also, just to keep in mind, assignment 1, part 3 is due this Sunday. That's February 28th, the last day of February at midnight. So you and your partners are supposed to get together and complete that. Last week, what we did was we did a little bit of a preview. We looked at assignment 1, part 2, and I also looked at your plans for part 3. Some of you had plans for part 3, some of you didn't. You had some vague ideas of what you wanted to do. Hopefully you've got more of that in line, as the third part is all about data persistence. That's what's happening. But this part is going to be a small game we're going to make. And what I want to do is enable the in-class exercise for you guys online. So let's do that. So that is in-class exercise number 3, which is an individual assignment. So what we're going to do is we're going to make this one going to be due, we'll say, because today's what, Wednesday? I'll make it to Friday or Saturday. I know that the mill likes Saturday. Friday, Saturday. Saturday, February is what I meant. And it's not the 12th. It's going to be the 27th, right? At midnight. That's when we'll make it due. Okay. And you need a couple of screenshots, from this one. It's also going to be important because this one here will allow you to make it available. As start date the 10th. Three, 4, 5, right? Yeah. Is that today at 6:30? What we'll do is make the other ones, just for now, we'll make them invisible. So you don't have to be bothered by looking at them and going, what is that? What is that? Hide from users. We'll add these in later on. For now, we're going to just hide these. There's no need for you to be bothered by them. And that's okay. But we're going to do ice number 3 today. So that's why I'm just setting things up for you. I've also put some assets we need. I'm not going to start you off with nothing because that doesn't make any sense, right? I want you to start off with something. So that's why I've given you some assets online that you can use. And we're going to get there in 1 second. I'm just going to go to content here. And if you notice, under lecture, there's also assets version 2. So please download this assets version 2. The assignment 2 game is going to be scene kit or sprite kit. Assignment 2, you mean like assignment in the next half of the semester after the midterm. It's not going to be a game. It's going to be a little app that we're going to make. We're going to switch gears a little bit because we can only do games part of the time. Otherwise, they'll kill me if I did games through the entire time. And I like games, but we also have to be reasonable, and you have to learn other stuff other than games. So that's why in the second half we're doing AR and ML, machine learning, and a little bit of augmented reality, which you'll have to do with your stuff. So I think that's a little bit better. It's kind of a shift in direction, but those are the two apps we're going to probably build based on the in-class exercise we do together. Okay, so on that, I've got you these assets, so please grab these assets from here, from our in-class exercise we're going to do. You're going to get you to build something with these, okay? And what I want to do to start off is let's open up a brand new Xcode project. So I want to go here. I'm going to choose game like we did last time and click next. And I don't want to click on integrate gameplay kit for this time. I just want to just keep kind of start a game, and we're only going to do Swift and Sprite Kit, and we're going to go with the name of the game, which is MAPD 724 Winter 2021 semester, and it's lesson 6. As an example, is the one we're doing, and this is going to be the one, like I said, now that you guys are mostly here, that we're going to use as a jump off point for next week. So hopefully if people aren't here, I'll make a small announcement that'll get everyone to do some of this. If you're not here even and you're watching the video, that's okay. As long as you watch the video and prep for what we're doing on next week on Wednesday, that's fine. It's not going to just be on Wednesday. I'm going to give you more of the week to get it done. So I'll start it on Wednesday next week as an example, and then you'll have until Sunday of that week to get it done. So that way it's not like just one day. I don't think that's reasonable given all the other stuff you're going to have going on that same week. So that's why I'm doing that. Okay, so hopefully that is going to help you. Let's do a couple of things here. So I just want to make sure that I'm all ready to go when we're going. Okay, so are you with me? Check mark if you're with me, X if you're not. I'm just going to wait for you for a second. So again, in the participants panel up there, kind of stuff, wherever you have your participants panel, you open it up. Let me know if you're ready to go. And if you've downloaded the assets, I know I see a thumbs up from Zamil, but the rest, hopefully you guys can also come along. And I just have one thing to do. And then we're ready to go. How about the rest of you? How about Dimitro or Juliana or anybody? Are you guys all with me as well, or how are we doing? Because I don't want to start, otherwise you're gonna.
Yeah, I'm with you.
Thank you. All right, so again, we're just going to click next. And what I want to do with that is save it as a Git repository. We're going to put this up online, and I will share this Git repository for you guys for two reasons. One, so you can get your in-class exercise done, and two, so that you can also have it as a jump-off point for next week as a starter. All right, so that's what I want to do with you. So again, it's going to be in a folder of your choosing. And then, so notice we have some stuff in game scene, and we have gameplay kit anyway, even though I didn't include it. Let's just get rid of and clean this up. So I'm inside the game scene.swift as well as the so app delegate, I'm not touching. Let's leave that alone. But game view controller, let's clean this up as well, just so that way there's not so much stuff. And let's run this thing and remember what we got last time. So hopefully I'm going to run on an iPhone 12 Pro Max. That's fine. And let's see what happens with that. Okay, and again, you see that we should get this. All right, so that's kind of the starting point that you had as well. So hopefully you'll have the same stuff that you had the last time. Okay, again, I'm just going to check to see if you're with me. I just don't want you to be left behind, right? So that's why I want to make sure you guys are with me. Okay, so you got your project, you've opened it up as an example, and you should be okay for what you're doing. Okay, so we got some check marks, yay. Some people are watching me. We're good to go. Okay, now what about that, the stuff I just got you to do with the zip file? So again, let's do a couple things here. I'm going to go back to East Centennial for a second. I've given you these assets version 2. And I'm going to take the same files that you see, assets version 2. And I'm just going to transfer them to my Mac. So let's open that up. And I'm just going to look at downloads. I'm just going to drag and drop those assets in there. And of course, it's not supported. How about copy paste? Copy and right click and paste. Why is that not supported? Send files with TeamViewer. No, we're not going to do it that way. That's for sure. No, 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 not now. Well, there's the other way we can do it. And the other way that I'm going to do it is this causing me a problem today. I love when things just don't go as planned. It's just awesome. All right. What I want to do, so what that is, let's just put it up on GitHub. Haha. That'll be the other quick way of doing it, or on OneDrive. Just so I can get it. So OneDrive. I got a messy OneDrive, guys. So you're going to see the back part of my life. All right, there we go. I'm going to go to courses and Centennial. I always have a backup. This is the great thing about OneDrive is you have a great backup, right? For wrong one. For the stuff that we've got going on. Let's see, do we have week 6 yet? We do not. That's okay. But I'm going to do one of these and drag and drop this in here, which should copy it in no time. There it is, uploaded. And now what I can do is I can go to my trusty Mac and download it. So let's just do it that way. It's just a really fast way of doing it. I frequently do that, actually. I have to tell you that when something doesn't work and I can't drag and drop it, then it's as simple as just logging into OneDrive or Google Drive, whatever. Or putting it up on GitHub or what have you is also the same thing. So you need to decompress it like normal. And then once you do, you should have downloads. Excellent. Excellent. Assets 3 is what it's called. All right, so you can see that I have my assets. So what these assets are, and you should have them as well, is a bunch of stuff. I've got audio, fonts, assets, which we're going to use later on, as well as images, which we need now, and sprites. All right, so we have some sprites and images. Let's pull in some basic images first. So I think what I'd like to do is start off with all these images. So here's where all these images. So again, I would probably do it under XC assets. Now, a lot of those we can pull in right in here. And again, if I go back to my folder, what if, and I'm just going to put this out there to you, what if I took this entire assets folder, assets 3, there we go. And what if I just pull this whole thing into my project? I recommend that. So let's just do that. Let's pull that in for now, and we're going to use it in a second. It says, do you want to make the copy? Yes, copy if needed. So we're going to pull them in. We can use some of them, but at least it's part of your project. And when I put it up on GitHub, you're good to go. I think that's an important thing. Okay. What I'd like to do is we need to put some of them in this XC assets folder because then we'll have access to them, right? So I want to take my images, and I want to, not all of these, but these are some of your assets for you to use. I definitely want my planes versus plane.png. Let's pull that in. So I want the plane. That's what it looks like. I also want the islands. So the islands next, as well as the ocean. Now the ocean is a GIF file. Question for you guys is, can I have a GIF file on iOS? Is that allowed? We actually talked about this earlier, but so what do? How do I convert this as an example as a file? Well, you'd want to try and convert this first. I want to see if I have it under sprites. I may just have that under sprites. I may not. So I need to convert this ocean file, and I'm going to convert it and put it up on GitHub for you. eCentennial. So that way we don't have any issues, because I know that in the past, what I've done is I've converted it in kind of a really easy way. Like I've done it kind of, when we're together in class, it's not a problem. But unfortunately, we're not together in class, my friends. So I have to improvise some of this stuff. So let us just open this up as strap to this. And then what I want is, I want to open up my image. And I'll talk about the image and what the problem with this. So this is the image right here, this GIF file. And I want to open it with, just a moment, open with Fireworks. You can use whatever program you want. I want to convert this to a PNG 32. So that's what you want to do. If you have the ability to convert it yourself, you don't have to wait for me. All I'm doing is converting it to a PNG 32 and saving it back out as a bitmap file, save as. And I'm going to save it as a PNG. And let's make it so that we're going to put it in the same folder as ocean.png for next time. Awesome. Okay, and let me just put that up on eCentennial for you. So that's the one thing I'm missing. So I just want to put that one asset on there for you. And you should be able to get it right from eCentennial. So please just go up to eCentennial, grab that ocean instead of the ocean that I gave you. And that's the one you're going to need, because otherwise the GIF file will not work with iOS, and that's a bad thing. Well, what about my thing? Can I drag and drop it? It says not allowed, right? So let's see if I was to try it again. If I do one of these, see, it says no, right? So I got to do the same thing with my little funny OneDrive for now, which is here. That's why I left it up. And let's just pull that over and here. And that should just suffice. Excellente. And I'll bring up here, and I'll go back to this and go back to OneDrive and grab that file too. Again, this is all part of our setup. So just so that we have everything the same for next week. So we'll save that as, it's not what I meant to do. Let's save it as download. And we'll put it here. Yes, it's fine. Excellent. And we'll minify this and go up to this. And here's my ocean. And I'm going to pull it first into my images folder, like so, just so that I have it. And then I'm going to copy it in here. Okay. So it's ocean.png that I'm pulling into this. Now you have your ocean, island, and plane. All right, that's a good start. Those three things is what I want to have, right? So, so for the next thing we need to do, we need to start thinking about how we're going to structure our project. Okay, so let's think about the game view controller a little bit as well. Okay, so if I go back to my game view controller.swift, as an example, I'll set up my buttons and all that later. But what we want to do is we want to think about the scene that we're going to go to, right? So I want to set the scene as an example as whatever the scene is going to be, right? I'm going to have my game scene is what I'm going to make here, right? So a very simple game scene. And for the game scene, as an example, we have right now, we only have one scene. It's called game scene.sks. That's the actual version. Let's get rid of the hello label, please. So no hello label. We want to get rid of that. Okay. And we also have a game scene.swift. Game scene.swift. And that's good. That's what we want in a game scene.swift. So what I want is to start cleaning this up. All right, so let's start doing that. And one thing we want to do is get rid of all that spinning node stuff that we did last time. So remember last time what we did was, let's get rid of this. Inside of our did move, right? Did move to view, which is what this function is. And I'm just gonna, again, we just want to save, give as much real estate here as possible as we start off, right? I don't really care about this label and the spinning node. So let's get rid of these things first. So get rid of them. And I want to get rid of them first like this, because then they'll have errors and we'll know when we can get rid of the rest. So we want all of this to go as an example. And, but we don't want to kill everything because did move to view, we want this one. So let's get rid of all this. So just cleaning it up. And everything to do with the SK node as an example for touchdown. As an example, let's just clean up our project to start. So that's what I'm doing here. And let's get rid of this. We don't care about that as well. And we want to get rid of touch up. And same thing here. As well as this touches began stuff. And the reason why we want to leave this part. So in touches began, let's leave that, but let's get rid of this. Just so that it's cleaned up. Okay, file, save. And let's just, I'm going to rejig this so it's the way I like it. I put my curly braces on top of each other. I think that's just a better way for me to do it. Then I can replace the header of the function. And it's a lot easier to do than what I'm doing. This is an important function. So this is where all the fun happens. Okay, so all the fun happens right in here. And close this up to continue. No, we're not going to do that. So that, and the reason why I mention this is because remember the update function, it updates at approximately 60 frames per second. So this function is called about 60 frames per second, approximately. So that means every 16 milliseconds, 16.666 milliseconds. All right, that's how this function is used. And we do all of our movement function and stuff like that in this function. So it's pretty straightforward what we want to do here. Okay. So the next part that I want to think about is I want to put, start thinking about how we're going to lay this out. One thing is also, let's just go, so I'm going to save this, file, save. I also want to go to my game controller.swift and clean some stuff up here. One thing I don't want is the node count. I don't care about that. Or I also don't care about show FPS. Let's get rid of these things. So we don't want to have those work. Let's also reorganize our files. Again, this is just all set up for us to work because, again, I like to, to make things work the way I want. This is okay. We're starting off with a game scene. And now for testing purposes, let's just run it and make sure it doesn't break. Okay, so we should just be able to run it now. And it should be a black screen, nothing on it. That's where I want you guys to start. All right, so we need a plan for how this game is going to work. And I'm going to explain it a little bit. And then next week, you guys are going to work on it a little differently than how we're working on it here. So you can see there's nothing going on. When I touch it and whatever, there's nothing, right? And this is what you should have as well, nothing, like literally black. So let's think about this plan, what I want to do. I have these assets. I'm just drawing here on the whiteboard to show you, right? So let's bring that ocean into play. So this is the ocean. So imagine I have this ocean, and this ocean, what I want it to do is I want it to scroll. So it's going to move down. Scrolling means it's going to kind of move downwards. Then what I want is I want my little plane, right? Let me just undo that change. So let's just make it a new thing here. So I want my plane, as an example, here's my plane, to move around. Maybe I'll use another program in this. Maybe I'll use Fireworks instead. It might just be easier for you guys to comprehend what I'm saying. I'm sure you guys all have no problem comprehending. I just want to make sure that you guys are ready to go. All right, so here's the ocean. Let's try this again. Here's the plane. There we go. So what we want is at a high level that I want you to picture our viewport. So let's say our viewport right now is kind of, we're going to start off with a viewport that is in portrait mode, right? So that's kind of up and down, right? Not landscape. And let's think about that. I want to have some kind of viewport in portrait mode. And let's think about the width and the height proportional to what it's going to be. I'm going to make it proportional to, let's say, an iPhone. So what would be, and I'm asking you guys because you should know, what would be the proportions of an iPhone, let's say XR? We can target, kind of the proportions for this. And how would you find this out, by the way? How would you look and see if I want to kind of do some, kind of outlining, whatever? How would I find out what the proportions are for an iPhone XR? I mean, I can look it up. I can Google it, but do you guys know what it is? All right, let's Google it. So again, we don't have to be completely accurate, but it's nice to be somewhat accurate, right? So just looking it up off screen here, 1792 by 828. So 1792 by 828. This is very large. So I want to kind of think about what the ratio is for that. So if I take a calculator and I take 1792 divided by 828, then we're going to get a 2.16 or whatever ratio from a width over, or height over width ratio, right? So however this is going to be 2.16. So more than twice the width is what this is going to be, right? But this is way too big and we want to make it fit. So there's some other tricks we can use. We can say 1792, what if I divide that by 2? Is that reasonable? 896 wide. Okay, I mean, that's okay. 896 is how wide this would be. So again, if I look at the rectangle, then I'm just planning here. So if I said 896, that's how wide the rectangle would be, right? 896. I think this is still too wide for our little example. So let's half that again. Just again, we want to make it so that it's half. So that's like divided by 4. So divided by 2. So that's 448. That's more reasonable. Let's do that again. 448. And then what we want to do is for the, actually, let's do it the other way around. Let's do it so that it's 828 divided by 2. Sorry. 828 divided by 2. What am I thinking? 828 divided by 2. So that works out to be 414. That's better. All right. So 414 might be a better ratio. So again, we want a width of 414 and we want a height of 1792 divided by 2. 1792 divided by 2, which works out to be 896. That's nice. That's nice. Okay, 896 is the height. So that's right. That's what I meant. So that's kind of a relationship of a phone, and you can see that my ocean is actually larger than my phone, right? So what I want is to kind of put this directly in the middle when it comes to planning, because this is what it looks like in real life, right? On in Xcode, something that looks like this. So here's what's going to happen, right? With the ocean sprite, we want the ocean to start moving downwards, and when the top of the sprite hits the top of the phone, then what we want is we want this ocean to reset to the top again and move down. So what we're going to do is this, but the problem is the ocean's too short, the way we have it right now relative to the size of my screen, right? So instead of having one ocean, we'll have 2 oceans. So let's duplicate this. So I'll say Control C, Control V. And now we have 2 oceans. And what I'm going to do to make this work, I'm just going to do those changes. And let's modify the canvas size here so you can see it. Again, this is all planning for what we're doing, right? So canvas size, right now we're looking at 1440. Let's make it 2880 from the bottom. So there we go. So it's 2880. And now we'll duplicate this. So I want to duplicate the bitmap. Let's Control V. And I want to put this up here. So this is a great example of what we're going to do. So we want to put this one here. We want to put this one here. Okay, so they're kind of layered so that it looks something like that looks like this. Okay. We can also start off again the exact place where it is. But what's going to happen is at some point when this top ocean, when the bottom ocean hits the bottom of the screen, and the top ocean hits this part here, then we want this part here, this bottom ocean, to kind of go over here again. And this way we're going to reuse our game objects, right? And we don't have to instantiate new ones. Instantiation is a bad thing. It takes up additional computational cycles whenever we include a game object, right? So it may look like there's a lot, but what's going to happen is it's going to kind of go down like this. It's going to keep going down, and it's going to look like it's scrolling, right? That's what's going to look like. What's going to happen. Now, there's a couple of issues here. One issue is the separation, right? So notice that if I look at the object, that there is clearly a line that's right here. Okay. So if we do it the way I'm saying, then what's going to happen is we're going to see this line move down the screen like this. And then it's pretty ugly, right? It's going to come to about right here and everything's okay. So instead, we don't want this line to ever be seen, ever, right? We don't want this line to be seen. So the way to do this, instead of doing it this way, right? Starting it up the top, like how I had it, like this and this, we don't want this to start like this. Instead, what we want to do is we want to start this ocean down here and this ocean kind of already here. That's what we want to do it. Or have that ocean start like this, where the bottom of the ocean's aligned with the bottom of the screen. And then what's going to happen is when this part of the ocean, if we did this, when this part of the ocean is here and it comes to this point right here, right? Then, we want to make it so that it doesn't, further go down. So this is one option. The other option is, right, because again, we're just going to scroll down the screen, right? Is when the ocean, again, when the ocean gets to the bottom, right? So again, you got to think about what's happening here, right? So when it comes to this point, right here, then what I want to do is right here, when it comes to this point, I want to reset this ocean to the top, right? And then let the other ocean come down. But then we're going to have this big white space. We're going to have this big white space. So we don't want that to happen at all. Okay, so this is one option. The other option is we make our ocean bigger, much bigger, right? So if we made it longer, like actually stretch the ocean so it's much larger, then where it's going to come down and everything else is going to be, it's not going to look as bad. For the ship, our little plane, what we want is for it to be restricted on the bottom part of the screen. Okay, so we don't want the little plane to be able to go up and down. Okay, so it's not going to do this in the screen. When you click on the plane, it's not going to be able to do this. The only thing the plane will be able to do is go like this. So we have to be able to think about how we're going to restrict it to go left and right. Okay, that's what we want. So background, and then this. And then we have our other object, which is the clouds. And that's the dangerous part. So the thing that challenges the plane is the clouds. When the clouds hit the plane, it blows up. Think about the clouds as, I don't know, they're radioactive clouds or something like that, okay? You know, that's what they are, okay? So let's bring that into play as well. So we're gonna grab a cloud. One thing we don't have is the cloud. And let's just make sure that that is the right size. This is the cloud, and this cloud is pretty big for our screen, right? So if I have two of these, there's a good chance it's going to kill our plane. And did we actually put that in on this side? I don't think we did. Let's do one more thing here, guys. I asked you guys to pull in under XC assets, the island, the ocean, the plane. Let's also bring in the cloud asset from the assets 3 folder. So there is a cloud asset, right? Here it is, cloud.png, this one. So what I want is for this one to be also transported into, here. Okay, so cloud should also be there. So cloud, island, ocean, plane, those 4 assets for now. That's all we need for today. So that's how it's going to work. So the cloud is also going to come down the screen. Again, it may need resizing. Okay, when it comes down to it, because we're taking assets that work on the desktop, and now we're trying to try and convert them to make them use on a little phone. Let's see how this works, right? So again, if I go back to fireworks for an example, then you can see that this is the cloud asset. It's going to come to the bottom. So this is our screen. So it's going to start, let's say, at the top somewhere in a random location, here, wherever it's going to be. And then what's going to happen is it's going to come down the screen in that random location, and when it leaves the screen, it's going to also reset to the top. So we have a resetting something again and again. We have something that keeps on resetting again and again. I'm thinking class in my head, something that is repeatable, something that I can inherit from, you know, whatever. That's what the cloud does. Same thing goes with the island. The island is where we're going to get our points from. So every time we run over the island, then we can think about collecting coins, collecting points, as an example. And what's going to happen is as the island comes into the scene, it's going to come in random positions, similar to the cloud, right? A random position across the x-axis. It's going to fall down here. And when the plane rides over the, oh, look at that. There's a different layering that has to happen. We have to also be mindful of the layering, whereas the, you know, everything, the cloud has to be above the player, like so. The cloud also needs to be above the islands and the ocean and the player. So the player has to come in order. So this is also something we have to consider, the order of drawing when we do our application. Again, here in fireworks, it's not a big deal. We can just say that the cloud bitmap, right, as an example, it's going to come after. So this is the one that's going to come after. And we have to, if we click on the plane bitmap, we want that to be kind of a little bit higher. Let's rename this. You can actually do this in any program that you want, Photoshop or fireworks or whatever. We'll call this plane just so we can map it. We'll call this cloud so we know what it is instead of just bitmap. And we'll call this the islands. And then finally at the back, we have 2 oceans. We have, let's say, ocean 1. And we also have ocean 2, which is this one up here. Okay, so we have ocean 1 and ocean 2. So we know we might need 2 oceans. We might. Okay, we'll see how it goes. So those are the assets. We know the oceans have to be at the bottom, but the island should be below the plane, like so. Then the plane, what's this rectangle? Oh, this is this. This actually should be way at the top. That's just our border for our thing. Let's just pull that down. So the rectangle is actually the phone border. So when we're setting this up, right? So here's our thing. So really the cloud should be above the player and the island. The plane should be above the island and the ocean. And as the plane passes over the island, it picks up points. However, if it hits the cloud in any way and we do any kind of collision detection, then big explosions. This cloud obviously is too big. Right now it's 226 by 176. We should probably make this at least half the size. So these are things we're planning to do with our assets. So again, if I said 226, then I'm going to have 113, right? If I made it one kind of half the size. We don't want it to look like this. This is skewed, right? As an example, we want it to be proportional. So we want to take 176, also divide that by 2 to give it the same proportions. Whatever you do to the top, you do to the bottom. So then that's 88. So let's make this 113 by 88. That's our plan. And that's a much more reasonable cloud than what we had before, right? So we can say that, again, as the cloud comes in, and if I had multiple clouds, let's say, for example, I had 2 clouds or 3 clouds, you know, as an example, let's say the clouds are coming in at different places. We don't just want the cloud to come in from the top like this. We also want the cloud to have a little bit of horizontal drift. So it goes maybe this way, maybe another cloud goes a little bit this way. Some clouds will go straight down. As an example, they have different speeds. Some clouds will be fast clouds. Some clouds will be slow clouds. You know, you want some variation in the game to make it look like they're new clouds. Otherwise, you know, it's too boring. It's already boring, but we don't want to make it that boring. Okay, so this is kind of very simple setup. And now after we've done our little plan, and this is what we're thinking, that is our plan for the game. Let's code it. First of all, any questions around this before we move on? I'm just talking about our plan, and always good to have a plan before you start, because otherwise we'd have to think about this on the fly, and that's always better. We have to think about how we resize. That is something we need to do. We also have to think about, do we want to resize the ocean sprites? And if we do, how big do we want to make them? Typically, what we want to do is whatever the proportions are of the screen, we want to make this ocean at least 3 times higher. So in other words, if this is our screen size, right, in the middle of our screen, the ocean should be at least 3 times taller than what it is, than the screen. So that means if our screen size, if I go to our screen size again, is 896, right, then the ocean proportionally should be at least 3 times that. 896, let's say, multiplied by 3, right? So something like 2688, right? Right now, the ocean is not 2688. The ocean is 1439, right? That's how high it is, or how tall it is, 1439, right? And we want it to be 2688, at least double what it is right now, each one, right? So let's adjust those as well. But remember, if I double the height, I also must double the width, because then it will be skewed. It'll look wrong, right? So if I said 1439 as an example, let's do this one first, the bottom, right? 1439 as a height, multiply that by 2 approximately, which is 2878. Let's do that, 2878. And let's get rid of the second one for now. We'll redo that one. And then the width of the ocean also must multiply by 2, right? Because the ocean doesn't make any sense for it to be 639, right? So let's multiply that by 2. So 639 multiplied by 2 is roughly 1278. There it is. So now it's multiplied by 2. So now that makes more sense, right? Because now what's happening is, if I start my ocean here, then what's going to happen is there's a lot more room for this to go down, right, before it hits the top of the screen. Also, for future planning, what if we wanted to make this game scroll from left to right, or if we wanted to make it work landscape, right, then we have more room. Okay, this way, so we don't have to do a lot of changes. So I think we need to also make our ocean much bigger, 1278 by 2878, at least twice as big. So that's plans. We just planned how we're going to do everything. Okay, let's get coding finally. So we could certainly add everything in individually, but trying to control each of these items is hard. It's very, very hard. So it makes sense for us then to create little classes, right, for everything. And I'm going to start with the ocean class. Remember how we did this before when it comes to the ocean, right? A lot of things are the same. It scrolls, so does the island. The island scrolls down, it goes down, moves down. So does the cloud. The cloud, the island, and the ocean, they all scroll down. That is something that they do, every single one of them. This calls for a superclass of all these things that we want to create. Okay, so let's make this the superclass, and we're going to call this superclass game object. Okay, so game object superclass is going to have a bunch of different things that we want to include. All right, and some of the things we want to include are things like the change on the x-axis, the change on the y-axis, the width and the height. We want to keep track of those things. For collision detection, we also want things like half width and half height. We want to have those things. Scale, is it colliding or not? We also want to have some random, the ability for us to call a random source and a random distribution in order for us to make some random numbers. Remember, randomly appear on the top of the screen. All those things are things that we need. And if we don't have that, then it's going to provide us some challenges. Okay, so that's how we're going to plan stuff. So let's think about our structure of our code, because what I want is to start thinking about these things. Okay, and here's what we also know. We know that everything is going to have some kind of update function. That every game object is going to have its own update function. Every game object must have some kind of initialization function, right? Every game object should be able to reset to the top of the screen again. We know those things as well. And every game object should be able to check to see what the boundaries are of the screen and if the game object has hit the bottom of the screen. So this is another structure. So there's two things. We need a class, and then we need a protocol. Okay. So remember, a protocol is more like an interface, right? This is kind of the structure. We're going to start with a protocol. Let's do that first. And again, Swift and Apple, it always talks about protocol-oriented programming. So this is what we want to start with. All right. So again, on the top left corner here, where we have our MAPD 724 less than 6, we're going to right-click here, and I'm going to add a new item, right? So a new file. It needs to be a Swift file. Okay, so a Swift file. Let's do that next. So a new Swift file. Yes, I'll show you everything in a second. We're going to call this the game protocol. So game protocol. Remember, think about this as an interface, right? So here's our game protocol. And the game protocol is, let's get rid of foundation. We don't need any kind of function. This is a protocol, right? So we're going to start typing the word protocol. And the protocol is going to be called game protocol. The game protocol is going to have the following function. Remember, what a protocol does is it defines, it actually declares function headers without any implementation details, just like any interface in any kind of language. So again, we start off with func, and then something like check bounce. So check bounce is the first protocol, right? And then we're also going to have another function called reset. I'm going to do them all in one because, and by the way, in reality, we would have multiple protocols here: a reset protocol, a check bounce protocol, or a boundary protocol, a start protocol, and an update protocol. I'm not going to have all those. I'm just going to do one, which is going to be called game protocol. But we want to separate them because then we'd have more flexibility, because maybe not all objects update, maybe not all objects reset, maybe not all objects have check bounce. So you can add the protocol that you want, and then you can define that function, right? But for now, we're going to say that all of our objects do the same thing, just to make it easy for us to understand, right? So that's a protocol. So our game protocol is pretty simple. It just defines a structure for our code, right? It's a handshake or a contract that we're going to make with anything that inherits from it or implements the protocol. Okay, we can say that if we implement the protocol, we must have a check bounce, reset, start, and update function in every game object that implements this thing. Okay, so that's the first thing, our Swift protocol. And what I want is I want to create a new folder. Let's put this in there and let's make a new group. All right. A new group. And we're going to call this group the core of our game. This is our core game. I want to take the protocol, game protocol, and put it inside of core from an organizational perspective. So we can organize the stuff that we're going to use. These are functions and or classes we're going to create and use outside of this area here, core. Now let's start the class. So again, in core, I'm going to right click and go new file. And here, just like we did, we're going to make it a Swift file. It's not going to be Swift, the other things that we had before. We're going to start off with basics before we start going. We're going to start to walk before we can run, kind of thing. Okay. So Swift file, we're going to click next, and then we're going to call this game object. Here's our game object.swift. Again, we're abstracting a little bit. We're going to use inheritance a little bit. And I know this is not always the right thing to do, but in this case, it will be. So we're going to do some importing. We're going to import sprite kit because we're going to need it. It's going to be a game object for sprites, right? We're also going to need gameplay kit because we've been using it down below. We're going to use it. We're going to make a new class. This is a new thing called game object. So this is the game object, same name as the actual file, game object.swift. And then what we're going to do is we're going to inherit from SK sprite node. Remember SK sprite node, the last time we did Swift, defines a sprite and it's a node type. So our game objects are going to have a relationship with this SK sprite nodes. That means they're all sprite nodes, every one of them. They're also going to implement the game protocol, right? That's the two things. So the comma, again, separates the protocol from the class that we're inheriting. And then this is the first part. Now it says type game object does not conform with the game protocol. Why is that? Because we don't have those functions. We need those functions, right? And what we want is we want to say, go over here and says, do you want to add protocol stubs? Absolutely, it's going to help us. Let's get those protocol stubs going. So I'm going to click fix. And it's going to actually put in place all these functions. Guys, this is way easier than if I was going to write all this myself, right? Because there's less fingers and pressing buttons. Less fingers pressing buttons means less errors, higher chance of success. Okay, so what we want here is a bunch of these functions. So check bounds, reset, start, and update. These are the functions we have. Oops. And we have some code that we're going to put in place. We also need our constructor function or our initializer, right? That's what we need. So we're going to have an initializer. And the initializer function that we're going to have is going to take a couple things. I want an image string, right? Because the image string is going to tell us which image which sprite I'm going to load, right? So I'm going to start off with image string. And it's going to be of type string. Okay, that's what I want. And I want also an initial scale. That's the two things I want, which is going to be of type CG float. Okay, so those two things. I want an initial scale for my initializer, as well as a string. All right. The other thing that it tells me is whenever I make a brand new class, I need something called init coder. I'm going to fix that. Let's just fix that. It's going to add in a stub. And I'm okay to leave it just like this. Don't even touch it. I'm not even going to modify it. This is required because I'm making a brand new class. Okay, so please leave it alone like this. Here's something that I'm going to do. I'm not going to define in my game object, I'm not going to define what check bounds is. I'm not doing that. Or what reset is. Or what start is. Or what update is. I'm not defining that here. Right? Because every object is going to have its own definition of check bounds, reset, start, and update. Now, what I could do is just get each object to implement the game protocol instead of me doing it here in my game object superclass. But every object's going to be the same. So then I might as well implement it here. Even though I'm not actually doing any implementation, I want to override all these functions in the classes that are going to inherit from these things. All right, let's do some initialization. So what I want is, let's talk about some instance members. Okay, so here, these are instance members. We're going to put them here. We're also going to we're going to call this the constructor, because this is in many ways what it is. It's really an initializer, but for us, it's going to be the constructor function, right? We also need to call the super initializer, right? Which is the initializer of, for example, the sprite kit node that we're creating, right? So we always call the super classes constructor. Same thing here in Swift. Let's think about the stuff we need before we do this one, though, because we're going to need to set up some instance members first before we get away with this error. So one is we want to define a change a speed across the x-axis, right? So we can call this horizontal speed or, just dx, all right? So let's just call it dx. It's going to be of type CG float, some kind of speed, okay? The other thing that we're going to have is define a speed across the y-axis, so something that's going down. So x-axis goes this way, right? And then, dy goes down. It's also going to be of type CG float. All right, so those two things we need. Like I said, we also want a width, and we also want a height. So we want to be able to, we want to detect or understand what the width and height is of each object. So that way, when it comes to doing collision detection, when we do overlapping, we want to overlap. We're going to do very simple collision detection in this game, right? Where we do some overlapping or distance checking, whatever we want. We want to have some of this information. And I don't want to calculate half heights, because we're going to do that half extents, if you will. We can also call it that way. And we can also make these floats into a vector, some kind of, X and Y coordinates as an example. I could do that. All right. But for now, we're not doing that. So like a point class is what that is. And we have that kind of half width. So CG float. So half width, half height. I'm also going to have a scale. I want to know the scale. I want to keep track of that for each object, as well as is the object colliding or not, right? Is colliding, which is going to be of type bool. All right. So a Boolean, yes or no, it's colliding or not colliding. All right. I want to be able to know. And then we're going to also initialize our random source, which is going to be a GK arc4 random. GK arc4 random source, this one. All right. So double click. As well as we also want a random distribution, because we want to be able to have some kind of randomness, random dist, we'll call it, GK random distribution. And this creates the two things we need to make random numbers happen, okay, in the game. All right, so these are all the think about the properties, if you will, instance members. We'll also call them properties. Not really, but they are kind of, they're going to be public. And then inside of my constructor function or my initializer, right, we want to initialize the object with an image. So we want to do that first. So let's say this initialize the game object with a texture, with an image, which is also in game, for game developers called a texture, okay? Image, bitmap, texture, same thing, okay? For you guys, it shouldn't be an issue. So we're gonna say let texture, right, equal to a SK texture. You can see that sprite kit knows what a texture is. And we're gonna pass in the image named. Remember, we're going to search for an image named some kind of image string. So that's where the image string is going to be used. So we're going to say that, hey, once I get the image string passing into here, then I want to initialize the texture. And the texture, think about it, is just an image in memory. I want to put it in memory, and I want to initialize it and use it. And then what I want is I want the color of the image. We'll use the American spelling for this, to be of type UI color dot clear. So we're going to have the color is going to be a clear color, right? And this is important. So no color basically at all for the image. Then we're going to call the super initializer. And the super initializer requires some details. One, we need to pass in the texture. So we need to pass in the texture. This is part of the requirement, as well as the color, as well as the size. Okay, those are the things. Notice that I'm using texture size. So, and what I'm doing is I'm reading how big the texture is. And because texture has been initialized, or we've created a texture object, that's what we're doing here, right? So SK texture is, it's almost like I have the new keyword. Every time I do this, this is a new, I'm using the SK texture constructor that's part of SpriteKit. And then what it's doing is it's constructing or creating an object memory called SK texture, self-type texture. And then it's storing the details in there. Well, textures, all textures have a size. So bounding area, X and Y axis, those kind of things. And we want to pass that into the super initializer. All right, let's keep going. So I also want to talk about scale. So my scale is going to be equal to the initial scale, right? So that's something that we want. And then we also want the, I want to set scale. Set scale is actually, because I can use set scale method or the function because my game object, my personal game object is of type SK Sprite node. It has a method called set scale that's built into all SK Sprite nodes. So what we want is the scale is going to be the scale of my object, which is just the scale. Okay, we want to put that in there. Whatever the scale is, that's something we want to pass in. I also want the width to be my texture dot size, right? Dot width. So we know the size also has a width and a height, multiplied by self dot, also say scale instead of self. So scale is what we want to do. Our height is going to be the same thing, texture dot height, sorry, texture size dot height, multiplied by the scale. So the scale is going to be uniform. Okay, I'm not, the scale that I'm getting in, which is going to be inbound from this part right here, this is a uniform scale. So uniform scale, which means both X and Y axis or width and height are the same, right? Could I have non-uniform scale? Absolutely. But if I have a scale, some kind of rotation and positioning, then I have a transform. And I don't have time to add that into the game object. So we just leave it like this. All right, so that is, set scale, width and height. We also want half width and half height. So half width and half height is going to look the same. We're going to say half width. We're going to pre-calculate what half width is when we start off. That's going to equal to the width, whatever the width is, and I want to multiply that by 0.5. And I'm also going to say half height is equal to the height, multiply that by 0.5. So this way it's pre-calculated. I'm not going to do that every single time. I can just call, hey, let's get the half width and half height as an example, and that's pretty good. Let's make sure there's an exclamation mark there, right? So we're going to unwrap it. And also we want self, we'll just say is colliding. We're going to say is colliding is equal to false. So it's not colliding. An object by when it starts, when we first make an object, it's not going to be colliding. And we also want to give it a name. So we're going to say the name of the object is whatever the image string is. So if I pass in plain, the name is going to be of the object is also going to be plain, right? So these are the things that we've passed in. Notice that name, I didn't make name. Name comes from SK Sprite node. All Sprite nodes have names too. And finally, the random source, we're going to instantiate it, GK arc4 random. So that way we just do it one time. So we're going to instantiate it as soon as the object is created. We also instantiate a random source and we can use it later. That's our game object, my friends. And that's a good start. So before I move on, the question I'm going to ask you is, are you with me? Do you understand? Do you need to go back and talk about this? Because you're going to code this next week, or you're going to use this code next week to make your game, and you need to understand it. So any questions so far? Rita says, is there a difference between overriding set scale outside of the init block versus calling set scale inside of init? Well, initializer, Dimitri, are you good, or do you have a question? So I don't know, is this being good? If it is, then give me that again. If it means you have a question, okay, good, thank you. Yeah, so the reason why we want to make it so that the set, if I call set scale inside the initializer, it's going to be called. Like set scale is going to be called somewhere. If I don't put it inside of you know the initializer as an example, then what's going to happen is bad things are going to happen, right? And your question is, if you override set scale outside of the init block, I mean, yes, I could, but why? Why would I do that? I would just set the scale to whatever the scale is here, and we're good. I'm not going to override anything. I'm just going to use that function. And if I really wanted to override it, I could, but I'm not going to override this. I'm just going to call the function that's actually a member function, right, to make it work. So that is thing. Let's put this up on GitHub so you guys have the same thing that I have, just in case you missed something. All right, so we're going to say file, save. And then what I want to do is I want to go to source control, and we've done this a couple of times. We'll do it again. I want to make a commit, and I want to say this is going to be my initial commit, right? So you can see these are all the things that I want to look at, commit 96 files. I want to call this the, I'll say added game protocol and game object. Yeah, that's what I did, classes. And I'm going to say commit 89 files. Those are them. And now I want to put this up on GitHub. So I want to push, but there's nothing to push. It says there's no remote, right? There's no remote to push to. So I can't push to anything. There's no remote. So what I want to do is I want to create a remote. Okay. So remember, this is not the only window for this. Let's pull open the our navigator window with a bunch of these, right? So remember, this is our project, and this is our repository link. This one right here, show source control navigator. And you can see that this is a remote. There is no remote. So I can right click here and I want to make a new remote. Okay, so again, I opened up my navigator and I went to the source control navigator, right? And I went to remotes and I right click on remote. Remote, remember what that is? It's a connection between our project and cloud. That's what we want to make. I want to make a new remote. And okay, yeah, sure. It doesn't know who I am, but it's gonna, hopefully this will work. If not, I'll just use a remote that's there already. But that's the remote, right? And here's my public. It's gonna be called MAPD724 W2021 lesson 6. But I don't want it to be here on mine, right? One thing it says I need to add an account. Sometimes this does that, especially when I've downloaded and installed. I've downloaded and installed this many times, like updated Xcode. And sometimes this needs one of those. So, and let's make a personal access token. I may need to do this offline, guys. Hold on a second here. I'm not gonna record this part. So I thought I already did this, but anyways. Profile photo, then click settings. Okay, so let's do that. So let's go to GitHub. Just a moment while I do this and while you guys pause. And I will sign in to GitHub. And I'm going to go to my profile, your profile. What does it say? Your profile, settings. Okay. There we go, settings. And what I want is to create a developer settings. Developer settings, excellent. So I'm following the thing there. And I need a GitHub personal access token on GitHub. Yes. And what does it say? Generate a new token. Okay. Generate new token. Excellent. What is this token for? Mac OS. Okay. And scopes. I'm just talking to myself here. I want it for repo stuff, but I also want it for administration. So workflow, packages, delete packages, admin, should do everything. Gists, notifications, users. It could be delete repo, write discussions, admin. Should do everything. And generate token. Awesome. There's my token. I think I got to download it now. Generate token, and then I download it. Copy it to clipboard. For secure reasons, after you navigate to the page, we'll not be able to display the token again. So copy to the clipboard. Okay. And then to use your token, authenticate that uses SML, so authorized token via SML. Okay, so what does that mean when it comes to this simulator? Enter the token, paste, sign in. And let's I gotta wait now. Worst case, guys, you know what I'm gonna do, right? This doesn't work. Whenever all else fails, whenever I have a problem with GitHub like this, it's command line. Like, I mean, instead of using something like of Xcode, and Xcode is finicky with this kind of stuff, right? Like it's loading account owners. Why do I want to go through this, right? So it says fail to load or whatever. Here's my account owner, right? So, you know, I don't, oh, there we go. Hey, finally, Centennial is what we want. We want this to be under Centennial. And I want to create and authentication failed. That shouldn't be the case. All right, so let's do it by hand. It's what it is. So what do you do? And I'm not going to have to fix this now because obviously this is going to be required to later. So how do I fix it? I'm going to obviously pull up a terminal window. I need to navigate to where my project is. That's important. So where the project is being saved, right? I wait till iTerm is finicky and loading up. Okay. Awesome. And just like before, if I go to here and if I say file, save as, show in Finder is what I want. And one more step up higher than that. Lesson 6, this one I want. Okay, so CD space, drag and drop. There's main, and let us do a list. Let's see if we have our Git folder. This is our Git folder right here. And we want to git remote add origin. And the origin remote we have to create. So we're going to do that by hand. That's fine. So github.com, and then we want to go to Centennial. Centennial. Come on. Make a new repository. And we're going to make it public. And we're going to call this MAPD724 in the winter 2021 semester. And it's lesson 6. It's going to give me steering directions, right, for this part. And I want all this. I want to copy all this. So copy. And let's go back to this for a second. And let's not do this part, but actually just right click and paste. That should do all the commands and press enter and stuff. All right, so so where is this now? I'm going to give this to you up online, fresh. And this is what it's going to look like. This is my project, right? So it's going to be here. I'm going to copy this. Actually, let's do it on the Windows side for a second, so I can give it to you here, right? So again, github.com/Centennial College. You can see it come up at the top here. And I'm just going to grab this link, which is what you're going to have to do for today, right? For your in-class exercise number 3, you need a GitHub link. So please use your link, not my link, to prove that you've done this. This is worth at least 1% of your final grade. Do this today. All right, and then what you want to do is you want to take this link, and I'm going to put this up on here so you can see it. Get a link, and this will be the week 6 GitHub link. So you'll have access to it as an external resource. You'll be able to do that in a second. And then here we go. It shouldn't say reps, it should say repos. There we go. That's just a typo on my part. All right, so right here. All right, so then it'll appear up on eCentennial. There'll be 2 parts. There'll be the lecture portion, and there'll also be a GitHub repo. And later on, I'll upload the video for you guys so you can watch this. So Muzamel says, we have to follow Sprite Kit for midterm part 2 of this. Can't be done with SwiftUI and UIKit. No, sir. It's going to be too much for you to recode, right? I recommend, and besides, Muzamel, you have to learn Sprite Kit at some point, right? Which we're making a game that's different than it would be working with SwiftUI. It's a game framework that we're using. SwiftUI is not necessarily. You can do games, but it's not meant for that. So that's why I'm asking you to do this way. Besides, new learnings for you. All right, so let's go back. So now that we have this and we put everything up on GitHub, then we're good to go. You have a copy of everything that I just did. So worst case scenario, if you haven't been able to keep up, you can always use my GitHub repository as a starting point for next week. This is the point of what we're doing, right? So now that I have my game protocol and my game object, this is a good starting point for everything else we're doing, right? Because everything else, I'm just going to close my door, guys. Sorry, 1 sec. We'll do the first game object. And after we do the first game object, then we'll take a short break and I'll do the rest. Even if I have to go to 10:30 tonight or even 11 for myself, I'll do whatever I have to do to make sure you guys are ready for next week. Hopefully it won't take that long. All right, let's go to the next part. So, so now that we have our game protocol and our game object, let's set up our first object that we want to do. And this object we want to use is our ocean. That is kind of our first object. That's the background. And I want to layer it in background order. So that is the first thing I want to do. So I need to make a new class, right? A new class is going to be called the ocean class, and it's going to inherit from game object. Okay, so I have my core folder. This is my 2 core classes. I use game protocol and game object. I'm just organizing myself because it's the right thing to do. Right now, what I want is I'm going to right click here on my MAPD project folder, and I want to make a new group. I want to call this group game objects. Okay. So these are the objects that I'm going to create from my game object class. Okay. So I'm going to right click now and I'm going to add a new file. We're going to call this new file, it's going to be a new Swift file again. And what I want for this Swift file, it's going to be called ocean, right? .swift. Pretty simple, ocean. And just like before, what we're going to do here is instead of importing foundation, we don't want to import foundation. We want to import Sprite Kit, right? And we also want to import gameplay kit because those are the 2 gameplay kit because those are the 2 frameworks we're using. I want to make a new class called ocean, and it's going to inherit from game object. Okay, it's going to inherit from game object. So it's going to be a game object, nice and easy, right? And what we want is you want to start thinking about the constructor function, which is the initializer. Okay, so we're going to say that in the initializer, it's not going to do anything. Here, whenever we initialize the ocean, we're going to call the super initializer, right? The super initializer. And what we want is this one, the one we made, right? Which is the image string. And we also want we want to call this image string the ocean. That's going to be our friendly name for what this thing is. Remember, The image string is also going to be connected to the image in XC assets. So let's make sure it's called the same too. Then we want to make an initial scale of, and again, this is something we got to think about, 2, right? Because if remember we said in our plan back in fireworks, we said, let's make this at least twice as large, because this will give us the ability for it to be wide and as well as long, and it'll be a lot easier to work with than if it's half the size. It's gonna be too small. So we're going to think about making it as a thing. It says also required initializer. We want the initialize init coder. We'll say, okay, fix it and add in that required initializer, which we're not going to do anything with. Now we want to override our lifecycle functions because we want to start thinking about overrides. Okay, so these are our lifecycle functions. I'm calling them lifecycle functions because I've defined them as in the game protocol, right? So what are they? We know what they are, right? I want to override, and I'm going to start typing override, right? What is it that I want to override? Well, think about this when I start typing. If I start override, then it has a couple of things as I start overriding. Anything that I can override is going to start showing up in my functions. All right. Anything that I'm going to start overriding. Right. So what can I override? Well, I can override this class, the function, right? That is the check bounds function, right? So there's check bounds that comes up, right? I want to override the check bounds function. And what I want to do to simplify this, because I know that each one of these is going to have a pattern, right? Is I'm going to go into, just to cheat, I'm going to go into my game protocols, my game protocol file here, right? So let's open up my game protocol file. So game protocol, grab all these functions, these function headers, these ones, or even my game object might be better because I have all these right here. I already have the curly braces and everything. Let's just grab this as a pattern, right? This is the pattern that I want to use for every game object, right? And I want to go into my ocean.swift and I want to put those in, right? So paste. I already have check bounds, so I'm not going to do it again. And all I need to do is put an override here. So copy, because I want to override each of those functions. So paste, paste, paste. So I'm overriding the check bounds function, the, did I do something wrong? I did, didn't I? Let me make sure I go, I mean, did I mess up? Function reset, function, no, I didn't. I'm good, I'm good. Sorry. So, and I'm overriding this because I'm going to make definitions for the ocean that are different than definitions for any other project I'm making. Let's think about what start looks like. So when the ocean starts off, what I want to do is I want to talk about the Z position. I'm going to say that the Z position is the order in layer, right? The order that the ocean is going to be. We want to set the Z position of the ocean to 0, right? This is the first thing. 0 means it's going to be the bottom, like we did here in our fireworks. The bottom of this is, if you think about this as the layer, ocean is first, then island, then plain, then cloud, and then so on, right? So that's how it's going to work in terms of how we're going to do Swift, right? So we're going to say, here's our ocean, my Z position 0. We also want to say that set some kind of dy. So remember, dy is a property that we kind of talked about, the speed. I want to set the dy, or the vertical speed, that's what it is, to 5. Okay, so I'm going to start off with a vertical speed of 5. And my start function, what we're going to use the start function for is for initialization. So that's what our start function is going to do. We're not going to do our initialization inside of the init function. In fact, what I want to do is I want to call start inside of init, like so. Why is that? Because it doesn't pollute our initializer. Our initializer should be nice and clean. It should do one thing, initialize, right? And it's going to call other functions in there, potentially do other things as well. Start is going to be our function that's public. I can always go to it again, and I can activate my start as many times as I want, right? I can't activate my initializer as many times as I want. It only activates once. Start can initialize, I call start as many times as I want. It's public, right? So this is the trick to this. Let's think about the reset position and what that is, right? My reset position. It's going to be some distance off the screen. We don't know what that value is, but it's got to be at least, as an example, at the top of my screen, whatever that size of my screen is. Now we define this, right? Remember what I said was we need to know the resolution, as an example, resolution of an iPhone XR, right? Let's say, or an iPhone 11, whatever, right? And we know it's 1792 by 828, right? So at the minimum, what I want is I want my reset on the y-axis to be 1792 pixels. Let's see what that works out to be. It might not be exactly what I'm looking for. We may have to come and play with that value a little bit more, but we need some kind of value for us to reset. So remember what the reset's going to do is going to take the initial, ocean. It's going to come down to this point right here, let's say. Then we're going to take the ocean, reset it back up to this, and then it's going to keep going down like this again. So if we look at this value, the ocean, and we look at the bottom of the value being here, it's going to move it to this position. This is the reset position, right? So the reset's going to come here. Then when the top of the ocean gets to the top of the screen, we're going to use one ocean, right? Then we're going to reset it again, and it's going to look like it's an never-ending ocean. So we need some kind of value. Again, we don't know what it's going to be, and we're going to have to do a little bit of playing. So I'm going to give it an initial value. All right. So again, it's going to be here. This is where my y-axis is going to be some distance down from the screen. We don't know what that is, right? That's the check bounce distance, right? And then we want to reset to the top of the screen, and I'm going to say that it's going to be something like 1792 pixels. I'm just making it up. We're going to see, this is going to be a trial that we're going to use. So let's suppose that the reset then is 1792 pixels, right? We're going to say that position. So remember, all sprite nodes have a position property, and position is a point. It has X and Y coordinates. So we're going to say the position on the y-axis, we're going to move it to 1792 pixels, approximately. Okay. For now, this is our trial. All right. So that's the reset point. Then for check bounds, what we want is, so we're going to say something like this. If my position on the y-axis is less than or equal to something like a negative value, I'm going to say something like 1500 for now. We don't know if that's right, but I'm going to say 1500. This is going to move down to a certain point, right? If we move our ocean down to about 1500, I don't know what that is yet. We can try it. I'll show you some tricks around this, right? Then what we want is the reset function to be called. So what's going to happen is every time, it goes down to the top, it's going to reset again to the top of the screen, right? So those functions are defined: check bounce, reset, start. We don't know these values are correct. Okay, we're going to check them out. We're going to play with them, until we find the right values. And then in our update function, right, we want to do some movement, right? So we need another function outside of our update function. This is not a lifecycle function. It's called move. Well, we could have made it a lifecycle function. We're going to say that my position.y is, again, we want a minus equal. We're going to subtract as we move down the screen, dy, whatever dy is. So we're going to subtract dy pixels or units from the initial position of y. So it's going to start falling when we move, and we call the move function. And then to make every update, that means every 16 milliseconds, we're going to call the move function, and we're going to call the check bounce function. And that's it. That's that's going to be our ocean class. questions around this? Because sorry, this is our foundational class. Without the ocean, then we can't do the other ones.
Shouldn't we check bounds before moving?
Nope, because we're gonna assume that the ocean initially is going to be put in a position, a start position. We could also, what we want to do, we also could reset the ocean, as an example in the start method. So in this, remember, start method is only going to be called once. So we could go in the start method, and we could try resetting, right away. So as soon as we reset, we could say that once we reset the ocean, then it's going to be at that start position. Okay. Couple of comments I have here for that we want to deal with, right? So Breda says we probably need to set these constant values based on the simulator specs we're using. Absolutely. That's why I'm just using test values right now. Next is Woosmel says the ocean doesn't have to move since place only goes left and right. We only make cloud and island move. Nope, that's incorrect. We want the ocean to move so it seems like the plane is flying. The ocean is going to look like it's moving as if the plane is flying. Okay, that's what it's going to look like. All right, so I like your thinking. I know what you're thinking about, but we're going to move the ocean. All right, so we're testing on an iPhone 12 Pro Max. I've been, kind of using an iPhone XR. I'm just going to switch to the iPhone XR and close down my simulator because I want to use the right values for my test. Okay, so let's launch my new project and let's see if this even works. First of all, a couple of checks we want to make inside of our XC assets. You have to make sure that ocean is called ocean with a lowercase o, which it is, right? And so are all of them, by the way, on purpose. They're all called lowercase variables. So cloud, island, ocean, and plane. If we look at the specs for these things, it talks about what the ocean is on the right-hand side, the image set that we're looking at. And we're basically making it fixed, okay? I'm not, going to change it, but it says individual scales. Gamut is, you can choose a gamut. A direction is fixed. Width class is any, right? So that means it can work with any class. We can also make it any and regular or irregular, any and compact for the width. It's probably going to be any and compact, which makes sense. And the height class is going to be any and regular because height is regular height. It's the whole height, right? But I'm not going to change this. Let's leave it as any for all these things, okay? It's going to be universal. It can work on any device. As an example, all of these things are going to be universal. All right, let's go to the next one. So if I launch it, do we get anything? Can I? Well, no, because we never instantiated a plane or an ocean or an island or anything. We're going to get a black screen again. We just made a class. We didn't do anything with the class, right? We didn't actually instantiate an object of type ocean, right? So this is our good black screen that we're getting. We still got some work to do, and then we'll take a short break. All right, let's stop this. So then that means that inside of the gameplay, gamescene.sks, gamescene.swift, and the gamescene.swift, this is where we add our code. All right, so that's the next place we're going to add our code. Again, a bit of abstraction, but you're going to see how this works out for us later on. So I want to do a couple of things here, right? And I want to make it so that I want to detect some stuff. So outside of the class itself, right? Outside of this, and by the way, I want to, even in my game scene, all right, I want to have access to UIKit and I want to have access to AV Foundation. Let's add them in now. So we'll say import UIKit. I want to have access to those tools, as well as import AV Foundation. Right, so those tools are for video and audio. If I want to hear sounds, which I'm going to do later on, I want to be able to do that. Next, I want to have some globals. I want to say that my screen size, right? So screen size, something I want to have access to is my UI screen .main.bounds. So that's going to give us a hint on what my screen size is going to be. And I also want to say that my screen width is of type CG float. And my screen height is also of CG float. Okay, so those two things. So screen size, screen width, these are outside the class. That means they're global. They can be used for any other class that's attached to this one. What I want is start defining some class variables. So instance variables or instance members, if you will. One of them is going to be called the ocean, right? Which is going to be derived from ocean. Okay, that's the one thing I need to kind of put in there. So ocean is derived from ocean, right? And that's the one I want to focus on right now. And what I want to say is that when I call the did move to view, I want to say that my screen width, again, this is answering Rita's comment before, my screen width is the frame dot width. And then my screen height is equal to the frame dot height. Screen width, the screen height, frame width, frame height. We're going to have some issues. I know we're going to have some issues. Just bear with me as we go for it. We're also going to have the name of the scene. The name of the scene is going to be the game scene. Yeah, that's the name of the scene for now. And what we're going to do is we're going to add the ocean. Okay, remember that just because we did this doesn't mean we've added anything. We define ocean as of type ocean, but now we have to instantiate it. And the way instantiation works as always is ocean is equal to a new ocean. And then after we have our ocean, right? Well, we have to define some stuff. We can say that my ocean dot position, my position of the ocean is equal to some kind of CG point, just to start off. And let's set it to 0. And again, some value. Right now, again, we can talk about this in a second, but it's like something like 1792, the same thing that we had before. And hear me out. I wanted to show you what this looks like. So 1792 is the value I'm going to use, right? We're going to also think about how to use this later on, and do we need this at all? So let's just make the y-axis 1792. If I can type. And then once I have my ocean in the right position, I want to add child the ocean, which is going to be the one that is SK node. Okay. We need to unwrap it because we don't know if ocean is going to actually exist. So we're going to explicitly unwrap, and this adds the ocean to the scene. Okay, that's what it does. That's in the did move to view function. So first, we define some game object, a game protocol for all game objects, and then we make a new ocean, and then we instantiate it. Okay. Once we instantiate it, then what we want to do is we want to move it, right? And the way we're going to move it is we're going to call the update function. So in the update function, way down here, this is the next thing we're going to call. In the update function, we're just going to say ocean.update. And that's it. The ocean should be part of our scene now. Let's go over this one more time so we understand the process, right? Because you're going to do your own as well next week, right? So let's look at this, right? So again, one thing we have is we have an ocean. We've created a reference. We've declared to Swift that we have a variable called ocean, which is of the shape. It's shaped like an ocean, but there's no, it's got null reference at the beginning. It's null, right? Then what we're going to do is we allocate memory. That's what we do here. This allocates memory, right? Memory, right? We set up the position and then we add it to the scene. Add object to the scene, okay? When we add it to the scene, it gets drawn. It's inside the display list. When it's in the display list, it's going to be drawn. That's how it works. Think about it as a scene graph. Okay, so that's how it works. If we did everything right and we didn't mess up, and I could have, right? Then let's see what happens if I run it now. Maybe do we see an ocean? If we don't, we're gonna have to consider why. Okay, look at that. Notice it started right at the top, right? And then it goes to the bottom, and then somehow it resets. So it's not quite what we wanted, but this is what the thing that I wanted to see was the mill. By the way, if you can't see it, let's make it a little better so you can see the optimized for video clip, so you can see it a little bit nicer. That should show you the ocean scrolling a little bit smoother, maybe. Maybe not. But it's wrong, right? It's wrong for a lot of reasons. It's wrong because we can see the ocean, and we should never see the ocean. It should have already reset up here. It reset too late. Rita says, is the did move to view the first function that triggers in the scene class? Yes. Move did move to view. When I move the scene into the view, as soon it's almost like view did load. Actually, view did load calls did move to view, right? So that's how it works. All right, so now this is wrong. Let's do some troubleshooting to make it right. And we have some tools for this, and then we'll stop. We'll take a short break. Okay. So we have an SKS file, game scene.sks. Now remember what we can do. We can use this for scaling and sizing, right? Right now, our playback speed is 1x, and we can zoom out, right? When we look at our scene, we can see the size of our object, like right here, okay? We can look at this, and we can start thinking about what would it look like if we brought an object into the scene, right? So what if, as an example, I brought my assets from assets, SK assets, right? What if I took an ocean and I brought my ocean into the scene? So the way to do that, of course, is inside of game scene.sks. We want to add a new object. We can do that here from the plus. I want to add a color sprite. Here it is, right? So color sprite is what I want. So let's try that again. Color sprite, right? And this color sprite is going to be added to the scene itself. So this is the one I want, right? The color sprite, right, which is what I want to add in here, is if I can add that in, that'd be nice, because then I can start playing with it, right? There's an empty, which is an empty object. These are objects that I can add in, right? And it's giving me a boop, boop. That means that I can't add an object right now to the scene, to this scene class, right? I can't add it in. So the name of the scene is called game. It has these objects, right? But I want to add that. I want to add a sprite to the scene. So can you guys do it? Maybe you guys have my Mac is what it is. Button. Oh, these are the things. Yeah. No. So these are the things that it kind of reads in my project, right? You can see I have a bunch of other things here, explosions, and a bunch of different things here, right? But what I care about is the ocean, right? So let's see if I can find the ocean sprite, which is an ocean ping, and bring that into the scene, right? It doesn't seem like to like anything that I do. Maybe you guys are having more success. Yes? No? There. Finally. All right, so this is not shaped properly, right? It's 640 by 1440. We made it double the size, right? So what we want instead is for this to be 2880. Remember, we're going to double the size, and then by 1280. That's what the size is going to be, right? Remember? And it's going to start way over here, I said, right? It's going to start at 1792. But 1792, look at the y-axis. 1792 is like a little bit off screen. It's not really showing what this looks like. This is the 0 point here, right? And if it starts at 1792, that is the y position. The x position should be 0. These are things we can test with, is what I'm showing you, right? So this SK sprite node, which is the ocean, is like off screen. and it'll be here. But what I wanted to start is here. I want it to start fully on screen like this. So it's not 1792 or some other value. It's 773 is what it looks like here relative to the scene. All right. Notice that this object is centered in the middle and that we start at a 0 point in the middle here. So 773 seems to be the right reset value. I'm looking at it right here, guys, 773. All right. And then let's mark that down. So I'm just going to use Notepad for that, just to mark it down. And we don't know if these are the right values, but we're going to use this as some measuring, right? So again, we know that the reset value could be 773, right? We think it is, okay? And what about when it resets? Well, what we want to do is when this thing goes to the top of the screen, like so here, minus negative 773 is when we want it to reset. And this is based on this values here that I have here, 640. And it looks like, we're proportional, right? So 640, it looks like by, or 1280 this way by, 640 on this side. So this is not the values that we're seeing here, my friends, are not reflecting of the relationship of where everything is. So this is negative 773 on the y-axis. So negative 773 is when it resets. 773 is where it's going to start. Let's see how that looks. So again, I'm just going to, it's 773 and negative 773. Let's delete this one. We don't need this as a test for us because we want to do it programmatically. And I want to go back to my ocean.swift. So instead of 1792 is way off, let's try 773. And then when the top of the screen hits the top of the thing, so it's negative 773, then it's going to reset to 773. Again, I'm using 773 as a number. May not be the right number. We want to see what it does. And also, we might as well start it off in our game scene.swift. So we'll save in our game scene.swift. This is the first part, right? To understand our world. 773, right? Let's, again, this is our initial position, right? Let's try that now and see what happens. Does it work? Does it break? Is it the same size? Does it make sense? Is it going to last forever? Are we going to see part of it? Or is it going to scroll and is it going to look? This is much better, guys, right? We see a bit of flickering, but that's normal because what's happening is we're doing this. So we're going down to the bottom and then moving to the top again. To avoid flickering, we need two oceans. Like I said, two oceans, but we're not going to do that here. We're going to keep it to one to make it simple. Those are the values. 773 minus 773. Are you with me? Check mark if you did, if you're with me, X if you're not. Here's something we have to keep in mind. That SpriteKit doesn't know the size of my phone. I'm choosing a value that is relative to what we're doing, right? And I'm not even using a value, but I know in my mind how big my sprite is going to be, twice as big as normal, right? I want it to be very long to give you this kind of room. So it looks like a scrolling ocean. That little flicker, I'm going to allow. Don't worry about it. It's just our first prototype, right? If I'm making a prototype of a game with SpriteKit, I'm going to do it like this. It's not animating moving mill. It's not animating. There's no animation here. What I'm doing is it's a trick. All I'm doing, right, is I'm moving it down the screen. Remember? I'm doing this. I'm taking my ocean sprite and I'm doing this. I'm just literally moving the Y values. I'm saying I'm going to start it here, right, at the bottom, like this. This is my phone. Imagine this is my phone, right? Right. And what I'm doing is I'm moving this down, down, down. The ocean's going to move like this. It looks like it's animating, but all it's doing is moving down the screen until the top of my ocean hits the top of my screen like this. This is the reset trigger, right? As soon as the top of my ocean hits the top of my screen, it's going to do this all the way back to the top again. And that's that flicker that we saw. To avoid the flicker, we use 2 oceans, right? Because then we can reset off screen, right? We're not going to do 2 oceans right now. We're just going to make it work with 1. If we had more time and this was a game course, I'd do a lot of stuff with you, but this is enough. So there's no animation. This is not animation. This is just movement. The reason why it's moving at all is because the update function inside of SpriteKit, right? So remember, if I go to the update function, and this is inside of my game scene.swift, the update function, which is at the bottom, this one here triggers, it automatically triggers 60 times every second, every 16 milliseconds. It just calls the same function over and over again. This is our game loop, if you will, right? Our game loop function keeps calling itself, let's say, or it's being called by the internal system, right? Based on a clock, right? At some kind of interval, right? The interval that we're using is 60 frames per second, roughly, right? And then what's happening is when the update function is being called, the global update, that's what this is, inside of my game scene.swift, it calls the local update of my ocean, which we defined in my ocean.swift. My ocean.swift, right? Its update function, which we're calling from the update function of, the global update in game scene, right? Calls move and check bounce. Move literally moves it down 5 units every frame. Every frame means every iteration, every update, every frame. Each frame is 16 milliseconds approximately. So every 16 milliseconds, this update is going to be called as well, approximately, right? It's going to call the move function, which does this. And then every frame, it's going to check to see, am I there yet? Am I there yet? Am I there yet? I'm not quite there. Am I there yet? Am I there yet? It's going to keep on doing this check bounce function, which is just checking to see if the position is in the right place. And then when the position hits the top of the screen, hits, the top of the ocean, hits the top of the screen, it's going to call the reset function. And the reset function is going to put it back to the starting position. You don't need 4 months extension. You just need to follow this thing, and the video is here for you to see. All right. All it is I'm linking functions together. I'm linking, classes together here. There's nothing for you to think about. All right. Just know that the update function is going to call all the movements. Anything we want to update, anything we want to move is going to be here in our update function inside each individual class, right? So we're always going to call the update function. We're always going to call the update function. And we're always going to put the update called the game objects update inside of the update of our game scene. So if you look at our game scene.swift, right, what we're going to do is we're going to call the update function of the other objects too, each one of them in sequence. So we're going to call cloud update. We're going to call, plane update. We're going to call island update, right? All those are going to be called update, 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 update every frame. And that's what's going to cause them to do everything. Abdul Rahman says every 6 milliseconds, the ocean's Y position value is reduced by the dy value. Every 16 milliseconds, not 6, 16, 1 6. But close enough. 16, yeah. 16 milliseconds, which is like, the way you know that is if you take, if there's 1,000 milliseconds inside of every second, right? Then what we're going to do is we're going to divide 1,000 by 60, and then we're going to get, that's how many iterations we can do approximately. Some phones that can do a higher number. Some phones will do less if it's an older phone. So maybe you can do only 40, 45, right? The more efficient, the more times we call the update function, the smoother it's going to look when it moves. Okay, and also the faster it's going to go. All right, this is a great place. We're at 8:30, kind of about the halfway mark here. We're going to take a break for about 5-10 minutes. Let's go to the washroom, get a coffee if you need one, or whatever. We're going to continue tonight. We're not going to stop. All right. I'm going to continue recording, and I'm going to put the recording up on eCentennial. Remember that this is going to be your base, your foundation for the thing we're doing next week. Okay, so for people that are not here, and also for your in-class exercise, it's going to be something you need to finish. If we don't want to move an image, if it's something that's static on the screen, we don't use the update. Yeah, because the update, we don't need to call the update function, right? The update function is only when we want to move something. Again, I want you to think about 3 types of game objects like we talked about in the past, right? There's a game object that can update. There's a game object that doesn't update, right? There's a game object that draws, and there's a game object that doesn't draw, right? With those combinations, I can make a game object that draws and updates. Think about that as our enemies, our player, our ocean, anything that moves is a game object that draws and updates. We call drawing rendering. It renders and updates, those 2 things, right? Then we have only rendering, a static background. For example, a scene, like a background, that only renders but doesn't update, right? And then there's something that only updates but doesn't render. A good example of that is a checkpoint or some kind of spawn point, something that a trigger that your character hits in, that no one can see. It's an invisible thing that happens in the background, an empty object, as an example, that doesn't include, any visible rendering. I don't have to add it to the scene. I can have as many of those as I want, but they can all update. They can all do their calculations. Maybe I have some kind of AI brain class or an AI brain object, and that object is maybe updates but never draws anything. Okay, so those are the things. Let's stop. Let's take 10 minutes. Right now we're sitting at 8:40. Let's come back at 8:50 and continue and add the other 3 objects and make it a bit of a game. Okay. So I'm going to stop recording here, and hopefully this will allow us to put everything up on eCentennial.